Hello everyone, a very good afternoon to all of you. I am Priyanshi welcoming you all on behalf of Solar Quarter Middle East and First View Group to our webinar on automatic innovative technologies in utility solar PV. Hope you had a good time in networking with your peers today. I take the pleasure to thank our partner Ecopia for extending their immense support to organize this event. I would request my team to please play the promotional video of Ecopia.
What do we know about the future? We know it's going to be data driven. We know it's going to be automated, operated with technologies far beyond our imagination, turning global challenges into sustainable solutions. But no matter how smart and sophisticated it will be, our future will be created by people. Those who see beyond the curve and stay ahead of the game. Those who dare to make a change and stand at the forefront of innovation, creating solutions while continuously evolving and improving. Mastering the complexity of extensive information analysis and analyzing it for real-time response and improvement. Scalability that will fit our demands, ensuring reliability for decades, fueled by long-term partnerships, unlocking the incredible future that awaits us. There's one thing about the future we know for sure. The sun will keep on shining. Ecopia, empowering solar.
Thank you, team, for playing the sponsor video. Here, I would like to make a small announcement. Attendees can post their questions in the Q&A box, and our panelists will answer those questions at the end of the panel discussion. Allow me to introduce the proficient panel lineup for today. Session experts who have joined us today are Mr. Dinesh Kannur from NG, Mr. Stephen Malden from Sun in Motion, Ms. Surmai Kaushik from PV Hardware, Mr. Jonathan from AMEA Power, Mr. Amit Singla from Ecopia. The session will be led by Mr. Dinesh Kannur from NG. Now I welcome all the panelists on the screen and I'll hand it over to Dinesh sir. Thank you so much. Over to you, sir.
Hi, Pranshi. Thanks for this introduction. I'm audible to all of you. Can
Yes.
you just confirm? Yeah.
Yes, sir.
Okay. So I will just try to briefly introduce myself. I'm Dinesh. I'm taking care of the performance monitoring and analysis of all the renewable fleet, primarily responsible for South Africa, Middle East, and the Indian region for solar, wind, and CSP. So I welcome all of you for this session for automation in the solar industry on the PV scale projects. Now, as we see the the strategies of the various countries are shifting towards the increasing the percentage of renewable content in their annual energy mix. So if we talk about the GCC region and particularly about the UAE, it is estimated that they are going to mix a renewable content approximately 50% by the end of 2050, and thereby saving approximately 190 billion USD in their annual energy savings that they are spending on the energy. Now you can imagine that how tremendous opportunity these guys have created for the renewable sector, and ultimately it is leading to the steep competition between the developers and so in order to sustain in the market, you will have to optimize your engineering practices, your operations, and when we talk about the EPs, bringing in the efficiency in all of the process or life cycle development of the renewable projects, it is not very much important for all of us to improve our levelized cost of energy. And if you want to improve your levelized cost of energy, certain discipline in your life cycle of the project has to be bringed in. Now, if you can see, if you want to bring in the efficiency, you will have to really shift on automation of various key elements of your project. Now, so it is a time now, industry has to think that the automation is the now need of all the solar projects. So now, considering this, I will request Mr. Stephen to share his view. What are the different technologies or automated system that he can foresee to be used in the solar plants, and now what are the impacts of use of these energies producing some little extra? Can you just give your views on this particular topic, please?
Yes, thank you, Dinesh. Yeah, so obviously now the industry is moving rapidly, and the the various technologies that always have formed part of our industry are now aligning to enable us to do things that we've not done before. So obviously, we're now seeing module manufacturers become more automated at a module level. You know, Longi have just released a module that is able to essentially drop a module through string level from fault monitoring our voltage and current levels and temperature levels. So the automation is getting to a point where it's no longer system holistic; it's component driven, which puts us in a completely different arena of performance. So we're no longer losing strings due to issue. We're losing a module that is then bypassed, and then the string is able to continue and perform to the best of its ability. So at that level, modules are really getting ahead, and I'm sure all of our colleagues within the other manufacturers will also begin to align. And not only that, not only at a performance level for modules, at a safety level. We have obviously rapid shutdown at a DC level now, which we've only ever had in certain types of optimization units that are associated with a module, not integrated to a module. Now we're seeing it fully integrated, fully automated, which gives us rapid DC shutdown, which will effectively help us with legislation, will help us with safety, will help us with people on site, and will also help in the event of catastrophic failure to stop a system failing any further, so that generation can continue on the other parts of the plant unhinged and unhindered, and this part can be operated on, and we can continue to fix this. I think the other big piece that we're moving towards now with regards to automation, which for me is key in the areas that are not really accessible, and maybe during certain times in our human existence, e.g. COVID, we're not able to be at site. The monitoring systems have come on leaps and bounds, and their access to the switchgear and to the inverters for testing, diagnostics, and even generation shedding is insane. And the fact that telecommunications is coming on with 5G and other forms of fast fiber communication, we're able to do things. I think, automation a couple of years ago, we would sit there and we would probably be a bit reluctant to rely on it fully because of the dead band in communication. Whereas now we're sat here and we're saying, you know what, actually telecommunications and data drive is as successful as the hardware and software, and we can become more reliant on it. We can actually sit back and feel that it's under control, whether we're there or we're not. Obviously, it's still going to move. It still has time to mature. Not all areas and demographics are set up to take automation and to be fully reliant on it. But I think we're moving into an age where pretty soon we're going to be less hands-on, more data-driven, more diagnostic-driven, and able to control our systems from the comforts of our own home and feel good about it.
Yeah, Stefan, I fully agree with you that nowadays data is the key, and if it's a kind of new oil. Okay, so the more we rely on the data, the feedback that we get from the data is going to help us to improve our operations and bring in the efficiency in the operations or the life cycle
Of
of the project.
course.
So as you can
And that
see,
goes hand in hand with increased performance from then on. Obviously, once these things they come into play and they become the new norm, efficiency will automatically raise. It will get better. It will be more secure. It may not be that it's always better from an efficiency point of view, but from stabilization and to ensure that we achieve that will definitely be more secure.
Yeah, yeah, I fully agree with you. Just to continue this, Mr. Muhammad or John, you would like to enrich the discussion that the Stefan has already given his point. So, Mr. Muhammad, can you enrich? Sorry, I can't hear you, Mr. Muhammad.
Mohammed sir, can you try without the earphones? We are not able to hear you.
Sorry.
Mohammed sir, can you rejoin? By the time Dinesh sir, you can take the discussion ahead with other panelists.
Yeah, sure. John, you would like to share your views on the topic that just now Stefan has opened up?
Sure, gladly. And just while Mohammed manages to sort out his audio issues. So yeah, I think Stephen already touched on it. And technology is the technology is there, the communication was there, but it was more whether we were ready to use it. And of course, COVID introducing the challenges it did, it forced us to implement it. And I think it opened our eyes to realize how we can do better remote monitoring of our facilities. And everything is there. We have comprehensive SCADA systems, so we're able to see every facet of the plant that we need to. We've got automated cleaning thanks to robotic cleaning. We've got predictive maintenance, so you can within the predictive maintenance you can already through depending on how you've programmed your system, you can already implement certain maintenance procedures, especially things like IV curves or even scheduling a remote clean. You can do that through the system already. So we have the capability, and basically we're in a position where we can collect enough data about the facility to actually decide when and how to do our maintenance, and that's vital. And it's forced us through COVID to basically look at these things about how we can manage it remotely. But now I think the awakening is that we're realizing that the functionality was there, and that we're able to do it. Something like a CMMS system, which is a computerized maintenance management system, where it would automatically order spares when you would run out, is now something that we can really appreciate, because it's we don't need our guy to go to the spares room and realize, oh, I'm out of fuses. It's going to be replaced. It's going to be ordered already through the system. So those kinds of maintenance activities are fairly important, and technology is vital for it. And what's great is the technology has progressed, but we're also progressing. So we're learning how to use it better.
Yeah, thanks, John, for sharing your views. So we all know that all the developers and the O&M companies are now under a tremendous pressure to optimize their expenses in terms of running the plant. And now it brings in the possibility that how they should focus on improving their LCOE. And and when we talk about the minimizing the O&M expenses, as you can see, most of the O&M expense is going on towards cleaning of the module, security, and all those things. So you rightly said that the robotic cleaning is one of the key to automate the sector now. And we have one of the industry leader, Ecopia. I would just like to view from Amit and Surmay. You both guys come from one of the robotic and one of the tracker system, how the technologies that you proposed can improve the generation of the plant. So first we go with Amit and then followed by Surmai, that how your technology can help us, the IPP and the O&M companies, to improve the generation and ultimately the levelized cost of energy. Amit.
All right, Dinesh. So, as you rightly said, like one of the key maintenance activities in solar plants is module cleaning. And as we are emphasizing on more and more solar installations, the plant sizes are also going up. Earlier, we used to have each site a few megawatts. Now we are talking about few hundreds of gigawatts at a single site, so single location. So there, the conventional way of cleaning using water, it's not sustainable. Not sustainable from water point of view, and also it's impractical as well. And the way robotic cleaning works is that and especially robotic dry cleaning options like Ecopia. So we do this cleaning completely automated way without any intervention of any manual labor, any other, even single drop of water. And this cleaning is happening at much higher frequency than the conventional way of cleaning. Because when we clean with water, we clean the plant with the like once in 15 days, once in 20 days, because each small portion of the plant is getting cleaned each single day. But with robotic cleaning, with robots doing this job, it can happen, every single night. Every single night, the whole plant can be cleaned. And with obviously with better cleaning, higher cleaning coverage every single day, obviously there's a higher generation which can be achieved, and which will bring down the overall LCOE and make the plant more cost effective and bringing in more revenue for our developer partners.
Okay, Surmay, you would like to?
Yes, yes, for sure, Dinesh. Thank you, Amit, and thank you all the panelists. In terms of a tracker, if you see, tracker is a huge part of the solar plant itself. It's almost safe to say that it's the brain of the entire piece. And to ensure that automation is acting on making the plant more efficient, making the plant more robust, making the plant ensure that the operational failures are less will automatically be an advantage for the overall LCOE. So on the side of PV hardware, on our trackers, to testify and to support in the O&M strategy for EPCs, we have a SCADA solution called Pro Insights. And Pro Insights is basically a software which will help you to see your tracker availability real time. And if you're able to capture your tracker availability real time, you're able to ensure that your plant is running or maximizing its generation as per the simulations that you have. And this SCADA solution is basically going to interface into the state board electricity grids or the SCADA of the plant, and it is going to give you real-time analysis of data. It is also going to store weather data on its cloud-based service, and it has got a industrial IoT gateway to support the other interfaces of SCADA. And this is basically created so that all your solar plants are integrated. Everything comes with a touch of a click. You can access it on your phones, you can access it online, on your PC, on your laptops. And this is an endeavor to not just make sure you are doing preventive maintenance, but you're also ensuring your tracker availability and you're reducing the overall costs of O&M. So this is something that we provide to all the plants that we supply, and it's something which really distinguishes our product and our tracker and others in the market.
So, Surmay, building onto this, in fact, you brought in a very important point of connected infrastructure, and that's the way to go as we are going for bigger plants and scaled up solar infrastructure globally. So, likewise, our robots are all connected to the cloud, and it can be real time monitored by our clients on very interactive dashboards that we provide to them, through which they can see which all robots work and what was the availability rate and which portion of the plant got cleaned and where it is where some problems are there. So it brings in this kind of a very visual manner, that it makes it very easy to monitor the plant without the need of having too many foot on the ground to see physically what's happening, as in case of traditional systems.
Yeah, I mean, just to elaborate on Sumay and Amit as well, from a developer's perspective, with regards to having this access to the trackers and to robotics, um, misalignment in trackers over a utility scale system, even though it looks fractional, eye level, it's absolutely huge across a utility scale project, because obviously you have tables that are mixed with strings, mixed with inverters at various points, and that misalignment can cause super amounts of loss generation across the whole system. So to be able to have that detail and that access to foresee misalignment and the problems that it could generate is insane for a developer, and for expectations and guarantees. Obviously, as a developer, you're always erring on the side of caution with regards to your guarantee and your expected generations. And you're constantly worried. I mean, if you speak to a lot of asset managers like yourself, Dinesh, I'm sure it keeps you up at night when you're close to that guaranteed generation. If you know that you're able to proactively see that you're getting to that bottleneck, I mean, it's a game changer.
It's it's PVH. It's not game changer.
Okay. Okay.
Sorry,
So,
I
so,
just had to
so
tell
just
you.
to yeah, just to cut short the discussion. So it's just like something nowadays. The just a single question to Surmay and Amit. Do you feel trackers or the robots are must for the solar plants? Is it a must aspect for the solar plants? What's your view as
So,
compared to conventional things?
as I said earlier, the way the solar plant sizes are growing up, and we are having like say gigawatt scale plant at a single location, I don't think conventional way of cleaning is going to work anymore. So I don't think, and my developer friends will agree with me that robotics is the way forward, and we cannot live without it. And to answer Stephen's concern, the way we are working is like we are working hand in hand with all leading tracker developers, so that their communication systems and our SCADA are always talking to each other to take care of these, misalignments. And the way we have designed our robots, they can maneuver in very, very challenging terrains and can handle various levels of misalignments between two tracker rows.
Right, Amit, I completely agree with you. And in terms of the fact of the matter that yes, trackers are here to stay as over fixed tilt, and robotic cleaning is the future as compared to manual cleaning or cleaning with water. Definitely, the first point would be on the energy generation that you get with trackers. I think. Solar technology is no longer nascent. All the fronts, all the pillars of this industry have grown a lot in technology and have built each other as partners to kind of come to a level where we are talking about several automations. So, of course, we cannot go back to the grind, we cannot go back to the wheel of invention and go back to technologies which were inferior in generation. So, I think it's only looking forward. For the trackers and for the robots, and I think it's here to stay.
Yeah, and one of the key aspect of the all the developers is that the technology is a technology, but it shouldn't be same for all the geographies. Okay, so the whatever the models or the technology that you're proposing for the Asia Pacific may or may not suit for the GCC and not suit for the US market as well. So I would like to just get some more insight about robotic or tracker, that what are the different challenges that you guys face while positioning yourself in the Middle East region, maybe in the MENA region. Maybe Amit, you can.
So, as you rightly said, all regions are different. They have their own challenges. And to cater to the MENA region and looking at the size and scale of the projects, our latest product, H4, it is designed specifically for such areas. One single robot can clean rows up to 2 kilometers long. So, we can really optimize the total number of robots required per megawatt of the plant, because of the vast areas of land on which solar parks are now being built. And considering all these challenges with respect to ground shifting or misalignments happening between structures. So the robot is designed in such a way that it can cater to all sort of very very challenging terrains. No requirement of any ground leveling. It can handle slopes upwards of 8 degrees, or handling misalignments between two tables or two structures in case of fixed tilt. So I think we are keeping in mind all these challenges, and on top of that, to keep it fully automated, the kind of communication infrastructure or the communication backbone that we have built, it's such a that when we have thousands of robots operating in a single large location, not even a single packet of communication is getting lost, and all the robots are able to communicate to the master server, which is cloud based, seamlessly. And that's how we are designing our MENA strategy, or the product specifically for the MENA region.
Yeah, but the projects are located in such a remote location. You didn't even get a mobile tower signals, right? So, how autonomous are your robots? Do they do the predictive analysis on their own, and do they decide their cleaning strategy? And how they are connected with the real time weather, where to start clean, when to stop cleaning? Can you just focus some more light on it?
Definitely, Dinesh. So all the robots are connected to the cloud-based master server, where this all intelligence lies about getting inputs from the weather channel or the local weather station, and basis that depending upon what is the sunset time and when to start the cleaning, or if in case of any exceptional circumstances where there's a dust storm during the day, we need not even wait till the evening to initiate the cleaning cycle. So that kind of intelligence is built into the infrastructure. And to answer your concern about not having mobile towers or mobile network in remote areas, we have multiple communication strategies. We can set up local communication infrastructure, and we just need one single point of internet connectivity, and through that we can connect all our robots using RF communication. So this is how things work. So we do not rely on just one input. Like even for weather, we are taking multiple feeds, including from the likes of Weather Channel, or having our own physical weather stations installed on site, which are in sync with each other. And on top of that, we use a lot of heuristics. So if there are few sites in the same region, and we know the wind direction, whether it has hit the first plant, but the other plant, which may be few 50 or 100 kilometers away from it, we can predict that the wind is going to hit that plant in some time, and we can take action accordingly.
Okay. So Surma, you would like to add up something in relation to the tracker?
Yes, in terms of the tracker, I think the challenges that we face, or the ways that a tracker is constructed in different regions, is predominantly because of wind speed and corrosion. These are the two factors that affect the tracker itself. So, in terms of corrosion, of course, use of the right materials, the right kind of steel with the right kind of galvanizing thickness, POSMAC, Magnellus, these kind of grade of materials, and HDG with a certain micron coating, which would be required to withstand that corrosion galvanizing period. These are site-specific studies that you take up and provide the material as per that. So that is on the abrasion and the corrosion part. Besides that, the wind speed. Of course, we know that the wind speed in these areas is very high. So designing your tracker in a way that you're using predictive wind algorithms to ensure that there is no occurrence of any kind of event because of the design of the tracker. So ensuring that your design wind code is at a safe risk category to consider, to ensure that there is no integrity issues, structural issues with the tracking system itself. So besides this is basically the O&M and the installation of the tracker. It's also the interface that it has with the RoboCleaner, because that would be the overall functioning and the generation of the plant. So ensuring that the robo is working on the tolerances of the tracker, is tested site specifically for the soiling losses, for the wind conditions, and all of these parameters before the site is commissioned, so that all of this data, all of this actual not practical but not theoretical but practical observations are taken into note while developing these technologies and interfacing them. I think that is the main challenge that or main proposition that a tracker has to solve.
Thanks, Sunmay, for giving most insight about it. But now I will try to shift my focus towards the developer. Maybe John or Stephen, you can answer or share your what are the different challenges or the key aspect that you consider while designing the projects, that what the future technologies that can be adopted for your project. Because what I can see is that the major IPPs in the region are now focusing towards bringing in their own O&M team, and not giving their a bread or butter to the O&M companies, whereas the smaller developers or smaller capacity projects, they still give the or they offload their O&M work to the small companies. Okay, so considering this scenario, what are the key the challenges or key points to be considered uh, while automating your solar project in the region? Can you just throw some light on it?
Well, I think any IPP is always concerned about safety. Safety should be a priority for any power facility. So basically, when you're having all of these levels of automation, you need to make sure that the automation has enough intelligence in it that it's not going to hurt anyone. So that's whether trackers have enough intelligence to make sure that they're not moving when they shouldn't be, and it's cleaning robots not going to be bumping anyone or hurting anyone. So that is one side. Another side is, of course, the fact that everything is related to electronics. So I mean, especially in the Gulf region, you become because everything is related to the microelectronics, and electronics can sometimes be subject to very harsh conditions because they're exposed out to the elements, especially in the Gulf region, is they get subject to high temperatures. So it's basically we're just wanting to make sure that things are going to happen as they should be, relying on these microelectronics that can sustain the temperatures. Another point of focus, especially when it becomes to wireless protocols, is spectrums. So your regulators in most countries are very particular about their spectrum and not wanting you to go outside of the bandwidth that you're limited to. So it's very important for us as developers to make sure that, yes, there is, for example, a wireless technology that can be applied, but it mustn't be creeping into any sort of frequencies or bandwidths that we shouldn't be touching. And because especially because you're going to be getting into a situation where there's so much equipment that is already communicating wirelessly. You do want to make sure that your uptime is there. And sometimes it can be seen as a downtime, even though it's just a communication error. So I think that's quite important. And lastly, I would say that it's cybersecurity. We've got all of this automation, and we need to, if we're able to remotely automate a whole bunch of functionality within our facility, do we have the cybersecurity installed to make sure that somebody else can't hijack it from us? So I think as developers we're learning. We have our worries, but at least when you're in touch with these tier one manufacturers, you're at least seeing these problems are being addressed. So when I, as the developer or even as the EPC, raise these questions, we're at least seeing that a lot of the good manufacturers already have the answers. So that's at least comforting.
Yeah, I totally agree with John. I think one of the things, all of the things that John's just touched on, is something that we're all very worried about. I think with regards to the collaboration between all of the different sectors, is what's helping us to progress so fast and is helping us to move ahead. It's at such a speed. One thing that has cause for concern now within the industry is that obviously as we move into this more autonomous digital world of asset management and development and design, the employee has to evolve with that. So the you have a very different engineer than what we're used to. The old school engineer, electrical engineer, mechanical engineer is a very different animal now than what it used to be. So we're moving into this time of okay, we understand our needs, we understand what we're trying to do to get to this level, but we also need to understand that we have to develop our people because they have to understand the complexities, not just on their specific training, but on the integration of other things that are part of their world now. So with Samay and with Amit's um, robotics and tracker systems, you're going to have an engineer who's generally electrically strong, but that now needs to be mechanically, electrically, electronic, and telecommunication strong. He has to understand all of those parameters. So that for me is probably, we all have concerns, but as Jonathan's just said, a lot of these concerns are being taken into consideration by all parties. But one of my main concerns is the people, the implementation of it, and the specialists that you now need, because that we're accelerating so fast that people also need to accelerate fast and go through that learning at such a pace.
Yeah, Stefan, you rightly opened up the topic of the engagement of manpower and understanding of their existing skill sets, improving their skill set in order to adapt to the new methodologies that IPP is thinking. Their skill sets are not as required by the industry now in terms of automation and the adoption of the robotic cleaning and trackers and all those things, but the Amit or Surmay, you would like to just provide us how you guys are planning that the technology is improving day by day. What we were using 2 years back is not existing in the market, and how do you position yourself in next 5 years or 10 years when you give the warranties or guarantees with respect to certain specification of your product, that yes, we are going to exist after 5 years, 10 years, and we are going to support with available spare parts and everything. How do you plan your future upgradations of your own existing model and support the IPPs in future as well?
Sure, Dinesh. So basically, I'll go first about with rapidly evolving technology scene. So what we are doing right now is we are investing very heavily into R&D. We have a 40,000 square feet R&D center in our head office in Israel, where we have multiple engineers engaged in continuously testing technologies which are going to be deployment ready maybe couple of years down the line. So, taking a few names of module manufacturers, when they, think about a new module design, even before they introduce it to the market, they want to collaborate with us and test it whether, we both are compatible with each other. So that's how we are, rapidly keeping track of all the evolving technology trends in the market and trying to adapt our products accordingly. And in terms of providing this comfort about how do we provide service support throughout the life of the plant, the way we do it is we try to get into, and in most of the cases, we have a long-term service contract with the developers along with the initial capex contract that we have. So it's not just sale of the robot and couple of years of warranty and then we are out. So
I think we lost you. Amit, are you still connected? You're on mute, Amit.
Yeah, sorry, there was some network issue, I think. So what I was saying that we do not just sell a robot, give a couple of years of warranty and turn away. It's not the way we work. So we work as a long-term partners for our clients. So we get into a 25 years long maintenance contract along with the initial sale. So that gives comfort to our clients that that piece of technology that they're buying is going to be sustainable throughout the life cycle of the plant. And at the same time, it gives us the comfort to sign back to back contracts with our suppliers, our vendors, to maintain the continuous supply chain of spares and parts required for maintaining these obligations. So far we have been there in the business for almost more than 9 years now, close to 10. The first plant, the very first plant that we established, we are still continuing to maintain it. We have our team for predictive and breakdown maintenance, which takes care of these installations. This long-term commitments, both by the developers and through us to our vendors, this is what helps us in maintaining the sustainability of this technology that we are providing to our clients. And the way it works is, even if we are making any major upgrades or any hardware or firmware changes, it's all covered in that comprehensive warranty. So even at say 5 years down the line, we are changing some major components, be it the control circuits or motors or sensors. So it's all part of the same maintenance contract, and our clients can always have that peace of mind that they don't need to really worried about different parts of robots being available for the life of the plant or not. I hope I've been able to answer the query.
Yeah, exactly. Because when the IPPs are adopting certain technology, it is very much important that they get a support till end of the life of the project. Okay, and specifically in the volatile market, one of the supplier who is leading today and 5 years down the line, he's no more. Okay, so in the industry. So Surmay, can you just give a brief about your action plan? How do you guarantee the sensors, or what are the different critical parts that you are using today for bringing in the automation in the tracker? Your back-end supplier are there in the market down the line, let's say 10 years. So how do you ensure that you support your customers?
Sure, Dinesh. So, in terms of the R&D, in terms of the new technologies that we brought for increasing the generation, it is the new controllers that we have, which use LoRa, which is a long-range protocol. So it's able to communicate wirelessly. You do not need antennas, and it's able to communicate to 2,000 gateways at a single point of time. And it's using algorithms, it's using adaptive 3D backtracking, machine learning, diffuse irradiation optimization algorithms. And that is how the controller is able to ensure that the motion of the trackers is in synchronization. There is no latency delays. So the overall availability of the solar trackers is more. So this is on the controller side, what we are doing. What we're also doing structurally is we have something called micro tilting. So micro tilting is basically tilting of about 2 to 3 degree of the structure itself to place the module in a direction east to west, keeping the north and south axis fixed horizontally. And basically, it's a mix of a tracking system plus a fixed tilt. And the further you go away from the equator, the more gains you can get through 3D through micro tilting. And we can see probably 0.5% gains to almost even 3% gains in the upper latitudes away from the equator. So these are some of the technologies that we keep working on and that we deploy to all of our trackers. What we also have as a USP, I would say, is that we manufacture everything in-house. We don't subcontract, or we do not have we do subcontract as well, but our core business is through our own factories where we buy the steel, we have the innovation, the technology, and we integrate them. So since we do this, we are able to deploy any new R&D, any new technologies to all of our trackers much before other players are. So we have an innovation center where we are basically trying out different iterations, we're trying out different algorithms, different optimization techniques, and we're deploying them on all of our trackers. So it is easier, it is faster, and that's why we are able to bring technologies which other tracker manufacturers are not able to as soon as we are. And in terms of the overall relationship with the plant for 25 years, for 30 years, I think Tracker, since we also have a Tracker SCADA, we are able to provide on-air hardware update on all of our Pro Insight SCADAs. And in terms of the warranties, the performance bonds, the availability guarantees, all of these also have contractual obligations now, in fact, for even over 30 years. So some of the projects, it's even 36, 37 years lifetime. So all of our products are designed especially for 30 years, 35 years, depending on the requirements of the site and the plant.
Yeah, thanks, Amit and Surmai, for your way forward action plans. How you are planning to ensure that the your customer remains satisfied customer for a long time, and you support them for a long time. Now, so when we talk about automation in the industry and specifically solar, where there is no moving part, everybody used to say that in the solar there is no moving part, but now trackers and robot is the moving part. Okay, so now I will just specifically go to the John. How do you feel that automation supported by digitalization will improve the LCOE? Means when we talk about digitalization, getting a data from the field, analyze using the machine learning, likewise PV analyzers, drone-based thermography. So how do you feel that automation plus digitalization will help to improve the LCOE? Can you just throw some light?
Yeah, thanks, Dinesh. So when it comes to operating your facility as an asset, there's two very important elements that you need to look at, and that's your data and it's your visibility. But if you encompass both of those, it's basically representation that's the most important. Now, bearing in mind that when you've got an operating facility, there's only really two things that you're able to control. Specifically in a PV plant, and that's your soiling and it's your equipment availability. So why I say data is key and visibility is key is because it's how we need to represent what's happening on the site. So, for example, we know that all of these top tier tracker manufacturers like PVH will do customized tracking angles at every single minute of the day, effectively. Right now, if you want to represent on your SCADA system, is every single tracker pointing towards, let's say, pointing just eastward, and some are pointing a little bit more west, and some are pointing a little bit more east, depending on the tracking angle that you should be having. Right now, to try and represent that is vital, because are these differences that you're seeing between your trackers the correct tracking angles, or the displacement? Is it actually owing to the customized tracking angle? It's very important that we have this information, and it's how we represent it. So I think that when it comes to this digitalization of assets, when you pull out your mobile device and you want to see how your plant is performing, you want to be able to have the information coming to you at the right time, because when we're coming in the right time, but also in the right format, because when we have the right information, we're able to make the right decision. And really, when it comes to something like this, is the better visibility, especially when it comes to a cleaning robot. You could say that based on the data you have, it makes sense to maybe clean in the middle of the day, because you would actually, even though you would maybe get a little bit of reduced generation while the robots are cleaning, and maybe not even at its optimal stowing angle, or more a cleaning preferred angle, you're still going to end up with a net positive in terms of your energy projection. So I think as an asset management, from an asset management perspective, this digitalization is very much about how much data we have and how we see that data.
Yeah, thanks, John, for sharing the importance of digitalization for and data analysis as well. Stephanie, are you still there? And what's your view on the adaptation of the drone-based thermography? So it brings the automation in some percentage that taking the cameras in the field, picking up one by one photograph, and then analyzing in the control room. Whereas the drone-based automation brings you the let's say 20, 10 to 15 megawatts in a day during a clear sun, and it gives a result end of the day that look, your models are affected here, hotspot, diode failure,
Mhm.
xyz. So do you feel this type of automation is also equally important when we talk about only robots and trackers?
Yeah, I think obviously the solar has so many extraneous variables that could affect it that all of these things have to be taken into consideration. Obviously, as Jonathan rightly pointed out, soiling in particularly in this region is an extraneous variable that can have a really catastrophic effect on generation if it's not if it's not looked at properly, and robotics certainly helps to ensure that that soiling loss is kept under control. But having said that, another issue that we face here in the UAE and in the Middle East is high ambient temperatures, which wreak havoc on systems that may not have been installed correctly. Where you have swelling on MC4 connectors, you have hotspots on modules, you have micro cracks on modules, you have electronics issues on PCB boards within inverters, etc. So drone photography is also thermography is very important from a basis of preventative maintenance, but also further catastrophic failure of a system. For me now, obviously, drones play a great role in minimizing the time also. So not just from the thermography point of view, but from an inspection point of view. So if you're just doing a quality inspection on module breakage, a drone is much faster than a man. You can take megawatts and megawatts of drones within footage within in a couple of hours, and you can essentially see that there's no breakages across your the majority of your site. And the guy is happy in his cabin with his VR and Oculus on. So I think all of these new technologies are helping us to become more sustainable, more advanced, more adverse, more agile. And I think they all should be given the time, equal amounts of time, because obviously these extraneous variables with climate change, I mean, we see it now. The data that we see from some of our systems this year is very different to what we've seen over the last couple of years. We are hotter at certain points. We are cooler at certain points in the year, which has not been seen before. So what we're going to start seeing now is all of the meteorological data that we take from previous climate data or PVGIS data no longer becomes reliable because it's no longer an average, because it's changed so much. So we have to rely on the data that's given to us as and when, and we have to, as John said, we have to be able to make the right decision, not based on the past, but based on the present, and then predict the future, because it's changing so rapidly from a climate perspective also that it's going to be hard to rely on old data. Um, the controlled side of projects with regards to electrical infrastructure, of course, we can see patterns of consumption, we can see patterns of usage, we can see patterns of frequency, because that doesn't have as many extraneous variables. But when it comes to weather and climate, we have very little control over that. And the more that changes, we need to gain control through digitalization and autonomy. And I think the more Amit and Samay and these guys in the industry, the more they put into, I mean, even I know Ecopia are working on thermal. I think they already have actually thermal sensors on some of their robots and prototypes. So it's already going that way at a robotic level, that we're checking for micro cracks, we're checking for soiling through the robotics, we're checking for thermography and hotspots through the robotics. We're paying attention at a rapid rate now, and hopefully we can continue.
Yeah, thanks, Stephen. That was much helpful, and yeah, really focused the importance of the automation using the digitalization, drone-based thermography, and all those things. So it was a nice discussion that we had today. We could see that the automatic innovative solutions that the Ecopia, the PV Hardware, and those guys are bringing in the system. Though there are too many players in the market, but we see some of the faces repeatedly getting this kind of innovative product in the market, and supporting the developers for improving their LCOE. Thanks for sharing your all views, all of you, Amit, John, Surmay, and Stefan, for your time. And I think we can move towards the questions from the audience now, Priyanshi.
Yes, sir. Yes, sir. So this is the first question.
I'm happy to take that one. I mean, it's one of those questions that can have multiple perspectives depending on where you sit. So for me, obviously, it's going to be very difficult for any government in the current economic climate to give free energy to anybody, and that's why we're having this transition to stabilization and to become self-sustainable in various regions, so that we're not reliant on other countries. If the government was to incentivize solar at that level, I would imagine that it would have a. It depends on how you look at it. It would have a positive impact if you are incentivizing the off-taker to go renewable. But if you're incentivizing the off-taker to take renewables at a lower cost, then it affects the developer. Obviously, now with COVID and with companies that are trying to come back and to reset themselves and to reduce their OPEX so that they can gain revenue and get back on their feet and stabilize, they need developers. They need someone that can financially back the company to give them that transition to renewable energy. So from my perspective, I don't think it will happen. I think the way we're going now, you see what's happening in Ukraine and Russia, and you see, you know, Britain right now arguably used to be the most resilient for power, is now probably the most fragile for power. The Middle East is now moving into a very powerful spot of being completely sustainable and transitioning to renewable energy to ensure it remains sustainable. So, difficult question, but I think from my perspective, it could be damaging if they give free energy away to the solar sector.
Yeah, and I will just try to enrich this question. It's a funny part, but it has happened in the COVID time. Okay, without quoting the name, location, IPP, or any country, what has happened? The government started in intensive providing some relief to the consumers, and as of a sudden, the demand increased. So increasing demand exactly impacted, or positive impact has happened, that the curtailment percentage has reduced. So
Yes,
nowadays the renewable assets are being badly impacted by the curtailment instructions from the off-taker.
it's true.
So
It's
if
true.
there is a demand, then curtailment will be less. So that's
Yes,
how it can also positively impact.
yes,
Contradictory
yes.
your, but all the way I will say that something which is free is not going to support the ecosystem.
Correct. Correct.
So moving on to the next question.
Yeah, maybe the John or Stephen would
Uh,
like to take
I
this.
Dinesh, I have a question on this question itself. I think in Delhi, we are giving free electricity, right, to consumers?
Yeah, so for I feel it's a long term. It's not a good decision. So something
No, no,
free is
and
not going
also,
to help the ecosystem. It's my
also
personal
there's a
view. Okay.
clause. There's a clause. If you consume up to some 200 units or something like that, it's free. After you exceed even one, it's like triple the cost. So it's a funny policy that they have.
Yeah, maybe I'm not fully aware of the policy, but it's just a personal
Yeah,
view that something which is free is not going to help the system.
of
Yeah.
course, yes, yes, agree.
Yeah.
Yeah,
So the
nothing is
question is related to the
free is paying
agri-voltaic.
for it. I was just saying that nothing is free. Even if government is subsidizing it, it is coming from the tax revenues.
Of course.
Correct, correct.
Yeah, I think agrivoltaics is extremely site specific. There's so many drivers with regards to agrivoltaics, vertical farming, plants. agricultural, how much produce these people make, how much energy they need to create. In line with the metric tons of projects they want to move. It's a really site specific exercise that you do with agrivoltaics, and at a tender level, yes, it could be competitive, but arguably it would be hard to find specialists at a competitive level to bid. I think if you're going to do agrivoltaics, then you need to go directly to a specialist first. There's not many in the market that can give you active quotations and give you exactly what you need, because it's a very specialist subject. You're not just looking at the photovoltaic segment of it, you're looking at the produce point of it, concentrated and ambient temperature heat dissipation underneath the modules as well to help growth, light direction to increase growth of plants and produce. So it's a very specialist area, which I would say is completely site specific.
Okay.
Yeah, and I think to add to that, the intention behind the agrivoltaic system is completely different to that of a utility scale energy system. So it's trying to be. You could argue that yes, some are oversized, but of course, like Stevens mentioned, there's so many parameters that you're considering in your overall design that is focused on your agrivoltaic sector. So yes, there could be some oversizing, but I think the spillover. It might be competitive in a tendering level, but you would have to be up against other agrivoltaic systems. At least that's the way I see it.
So let's move ahead with the next question.
This has got Amit written all over it.
Yeah, sure. So actually, very happy to answer this question. Basically, it all depends on the dew point. Basically, humidity in itself is not that important. Basically, once the dew formation starts, that's when the dry cleaning becomes ineffective. So it's a temperature of both relative humidity as well as temperature. So we have seen in multiple geographies we can go even up to 80% relative humidity, and in some cases we have to stop even at 60-65 percentage humidity as well. So to sum it up, it's site specific, but the range is broadly 60 to 80%.
Thanks. So this is the next question.
Maybe John.
Well, I think this is not even a $1 million question. I think this is $1 billion question, and I think I mean, the entire industry is really trying to see what methods of storage make the most sense. Practically speaking, there's multiple types of storage. BESS is of course one of them, and when you're talking about BESS, you're obviously talking about a chemical battery. But I mean, there's potential energy storage. There's pump storage. You just need to look at a newspaper and see that the industry seems to be banking on hydrogen as a storage metric. So I guess to answer this question, I guess we'll wait and see.
Yeah, I think there's too much to wait for to answer that one. I think there's a lot of different elements and applications available to us, but I don't think anyone has the golden answer. And if any of us do have the answer, I'm pretty sure that we're going to be on the Forbes list in a couple of years.
Absolutely.
Okay, so moving ahead with the last question for the day.
Yeah, actually, the minimizing the temperature of the module is something industry is now facing a challenge, because the projects are designed with a certain degree of temperature consideration in the simulation softwares like PVC and most of the industry using it. and what we get at site is that the temperatures are not as per the basic design parameters, and always the O&M company comes, look, I have calculated temperature corrected PR and it is exceeding my budget PR. So everybody is struggling with this answer. So as far as technology, if to the best of my knowledge available, what solutions we are doing is that growing a kind of vegetation which does not impact as a shadow on the module, and thereby reducing some kind of a reflectivity, as well as some kind of minimizing the temperature around the modules. Apart from that, Stefan, John, if in your more knowledge, is there any technology to reduce the temperature, working temperature of the module during the peak time, that can help to generate more in the peak time of the solar?
I think it's a, as you say, it's a really tough question because um, the people are toying now with sort of like forced ventilation and fan systems. You're also looking at ergonomics of the systems through wind tunnels, and obviously Sumay will probably tell you a little bit more on how you could angle the modules at certain points to decrease temperature, through the tracker system as well, to create a corridor of wind to cool down to increase generation. So but I don't think there's a single method that is out there that can fix that problem. I think it's a holistic approach from design, mechanics, electrical engineering, and even they even have nano coatings now on modules to try to decrease temperature in these pieces. But I think there's a lot of different things, but I don't think anyone at the moment has cracked one technology that can help. I think it's a multitude that come together. John, I don't know, is
Yeah,
there
and I
anything you
think
think? Or?
so. What I can say, and it's going back to what Dinesh mentioned, is we just need to be careful because in the ambient temperature is of course one side of it. There's of course the fact that there's just irradiance hitting the surface of the module, and that's generally increasing the module temperature. So we could be perhaps cooling down the modules, but we're, especially somewhere like the Gulf region, we're reducing our albedo gain, and bifacial gain is not negligible. It can, we're seeing massive percentages uplift, throughout our facilities, and it's we're banking on that. So it's almost like, yes, we can take the knock on the slightly reduced temperature performance, but do we want to be touching? Do we really want to be touching the albedo? So I think it's two sides. And when it comes to forced cooling, again, it drives up your maintenance cost. It's Dinesh, you were talking before about moving parts. So now we're introducing more moving parts, and is that really going to be helping us in the long run? Yeah, like Stephen said, there isn't a standardized approach with the industry. I suppose it just comes down to your design, along with the tracker manufacturer, to try and make sure that you don't have anything restricting airflow behind your module.
And
I think,
sorry, Samay.
sorry.
Yeah, I think if in the future, with the way modules are advancing now, obviously it's a very physics-based issue that we face with temperature and the issues it causes with electrotechnical installations. Obviously, higher temperatures, higher resistance equals performance issues. So I think obviously once modules crack better temperature coefficients at cell level, that may also give us a much better outlook, rather than trying to look at an external component to resolve that issue. I think it's probably going to be an internal physics component of the cell makeup that helps us.
Which we're seeing. We are seeing
We're already
vastly
seeing this,
improved temperature coefficients in module. Yeah.
for sure.
I also think it's driven by a lot of the things on the site, like the placement of the inverters, the placement of the string combiner boxes. If they are put in shaded areas, I think that would probably reduce the temperature as well. And I think it's also the painting, the kind of painting that you're doing, that you're using on the steel or on the panel mounting structures and the panel rails, which are less absorption, which have less absorption towards heat. So I think some of these things are already happening on site for all of the plants.
All right. So we'll wrap up the session.
Okay, I
Yes.
think
So I would like to thank you all and thank you very much all the esteemed panelists for this wonderful session, and a very special thanks to Dinesh sir for superbly managing the session. We will now be thank you to the audience as well for taking part actively in the Q&A session. So, once again, thanks to our partner Ecopia for extending their remote support to organize this event. We promise to come back to with more such exciting session. The floor is now open for networking. Thank you. Thank you, everyone.
okay. Thank you.
Thank
Thank you,
you.
everyone.
Thank you,
Thank you,
everyone.
everyone.
Bye bye.
Thank you, everyone.